Hello, everybody. We're going to take a look now at how to solve problems with Venn diagrams. Okay, so let's get started and straight into it, and let's have a read of this question. So we've got some information about students who play football and hockey. So let's start off with our Venn diagram, and let's think about the students who play football as F and the students that play hockey as H. So we've got 8 students that play football and hockey. 7 students who do not play football or hockey. So I'm going to start by writing that 7 on the outside. Now, we've got 13 students who play hockey and 19 students who play football. So let's put some more of this information in. So we've got the 7 on the outside. Well, first, the next thing is we've got 8 students who play football and hockey. So that is going to be our intersection, look, because they used and as their description there, look. Okay, so we've used that and we've used that, right? So we've got 13 students in total who play hockey. Now, we already know that 8 of them also play football. Well, that means there's going to be another 5 to make that circle add up to 13. And finally, we've got 19 who play football. Well, that must mean that there are 11 left over, as well as the 8 that also play hockey. Okay, so we've completed a little Venn diagram. So our question was, how many students are there in the class? Well, we just need to add these numbers up. 11 and 8 is 19, plus a 5 is 24, plus that 7 is 31. We have 31 students in the class. Okay, now let's have a look at another question. We're going to increase the difficulty as we go along. So in a class of 30 children, there are 20 who can swim and 25 who can ride a bike. There is no child who cannot swim nor ride a bike. Let's draw that Venn diagram. So here is our circles. We got the swimmers and we've got the bikers. Okay, now we know that that entire swimming circle adds up to 20, and we also know the biking circle adds up to 25. But we can't yet figure out what's going on in each of those particular sections, so we're going to use a little bit of algebra. So let's think of that intersection as being x. Well, that means that if our swimmers add up to 20, then this area here must be 20 minus that x. And if our bikers add up to 25, well, that means that this area on the right-hand side is going to be 25 minus x. Okay, now, because no one is on the outside, these 3 sections must add up to the total of 30. So I can write down that 30 is 20 minus x, plus that x in the middle, plus 25 minus x. Now, we can simplify from here, and minus x and a plus x cancel out. We're going to be left with a 45 and a minus x. So we can think of this as solving the equation, or you could just imagine, what number do I take away from 45 to make 30? Of course, x is 15. Okay, so now I know that x is 15, I can redraw and recalculate this Venn diagram with that information in it, and this should help a lot. So there are 20 swimmers, 15 are in that middle part, then there are 5 that don't ride a bike and swim. And if there are 25 bikers and we've got 15 already, then there are 10 there, look, that don't swim but do ride a bike. Now we can answer these questions. So, A, find the probability that a child selected at random can swim and ride a bike. Well, it's 15 out of the 30 in the class. So it's 15 out of 30, which simplifies down to being a half. B, cannot swim, but can ride a bike. Well, there are 10 people out of the 30, so 10 out of 30, that can ride a bike but can't swim. So that simplifies down to 1 over 3. Can swim, but cannot ride a bike. Well, there are 5 people in that situation that are swimmers but can't ride a bike. So it's going to be 5 out of 30, which is 1 over 6. Okay, let's carry on. Let's see if we can figure out some more questions. So in another group of 40 students, 6 are left-handed, 18 have size 7 feet, and 2 are left-handed with size 7 feet. Draw a Venn diagram. Okay, so we've got information about left-handedness, let's call it L, and we've got information about foot size, being a size 7 foot. So let's use F there, look, okay. So we've got 2 that are left-handed with size 7 feet, so I'm going to have that intersection as being worth 2 people. Now let's go back and read the rest of it. We've got 6 in total that are left-handed. So that means I've got 4 that are left-handed that are not size 7. And if I've got 18 that have size 7 feet, well, I've got 16 there, look, that aren't left-handed. Now, we've got 40 students in the class in total, and I've already accounted for 22 there. So that means I must have another 18 left over that are in neither circle. Okay, so let's answer this question. So find the probability that a student is left-handed or has size 7 feet. Now, notice they say or here. It could be either. So there are 22 people in that situation, 4 and 2 and 16. So it's 22 out of 40, which is 11 over 20. Right, let's carry on. B, not left-handed and does not have size 7 feet. So this means that 18 on the outside. So it's going to be 18 out of 40, which is 9 over 20. C, not left-handed and does have size 7 feet. Well, this I can see from my diagram. There are 16 people in that situation. So it's going to be 16 out of 40, which is 8 over 20. We can go again. It's going to be 4 over 10, or in other words, 2/5. Okay, final question. Let's do a really challenging one to finish off this video. We're going to read this very, very carefully because it is a tricky one. Right. When a person is selected at random, the probability that they are left-handed is 0.08, and the probability that they are female is 0.52. Now, already I'm going to start to think about this. I'm working on information about left-handed people and females. So I'm going to use L for left-handed and F for female. Okay. If the probability that a female is left-handed is 0.042, find the probability that a person selected at random is female or left-handed. So this is a really tough question. If the probability that a female is left-handed is 0.042, so that means that our intersection here, look, is 0.042. Okay, it's kind of like the both things combined, right? Now, from there, we can work it backwards to think about the missing probabilities that go here and here, because I've got that the total probability that someone is left-handed is 0.08. So if I do 0.08 and I take away 0.042, I'm going to be left with that area, look, in that space. So that is going to be 0.038. Now, the probability of someone being female is 0.52. So my total circle is 0.52. So if I do 0.52 minus 0.042, then I'm going to have the the value of that space there. Well, that is 0.478. Okay, so now let's just get rid of all that working for a second so we can see clearly our answers. Okay, so from here, we were asked to find the probability that a person selected at random is female or left-handed. Well, that's going to mean adding up each of these 3 things because they're asking us there for the union. So if I do 0.478 plus 0.042 plus 0.038, we're going to have an answer of 0.558. And that one is correct. Okay, I hope that helped and you understand how to problem solve with these Venn diagrams.